Let me present my screen. So guys, as you see my screen, in last call, we discussed about AWS glue, right? And we perform this operation. I will just quickly take you through those whatever we did. Let me see. I'm sharing the rights. Yeah. In last call, let me move this thing over here. Yep. So in last call, we talk about guys, what is AWS glue, and we discussed that glue help us to create a data catalog wherein with the help of glue, what we can achieve is like I was presenting on screen. Let me quickly take you through that. The PPT that I have. Yep. Yeah. So last week we were talking that what is AWS glue, right? How it help you to connect to a different system and generate other basically data catalog out of it, right? So we talk about use case wherein it connect to your Amazon S3, right? This AWS Glue catalog connect AWS Glue with the help of crawler connect to AWS S3, and then it scan data from all these sources. We give the example of S3, but it can connect to any as the data source that what we are seeing. And also in last call I showed you there are other data sources as well. So what is the purpose of Glue, right? It connect to different system, then generate the data catalog. What is the data catalog? It's nothing but the logical database, right? You, when I'm saying logical database, it's just the metadata information you have in data catalog. Actual data reside in this location, but with the help of logical database and logical tables, you can query the data which is reside at this location. So that's the main goal of or main feature of Glue, right? From the single place, you can connect to on-prem sources, Amazon RDS, Redshift, NoSQL, SQL databases, anything, right? And at a central place, you will get the single source of truth. You can get, let's say, for example, just giving example, you can generate the 20 databases by connecting to different sources, and in each you might have many tables, right? So you see, you are you getting the power of that? At a single place, you can query all these databases, right? Tables, and generate some insight out of it. And then of course you can query it with the Athena. We've seen that with how to query it with the help of Athena and Redshift, right? So that's what we seen guys in last call. And also we seen with the help of AWS Glue, there are two options. So when your crawler crawl the database sources, it generates data catalog. After data catalog got generated, what you do, you apply ETL on top of it. So to apply ETL, I showed you two approaches. One is ETL means extract, transform, and load. Two approaches I showed you. One is low code based solution with the help of visuals. Okay, you just do drag and drop sort of things and do the transformation, connect to the data source, connect to the data destination, and all, right. So those sort of things you can do and load data into the respective target system, right? So that's what we seen in earlier call. And then we also did with the help of AWS Glue notebook, right? With the help of notebook also I showed you that how to connect to the different system, process data, and how to load that process data into the databases or any destination system. So that's what we seen in earlier lecture. Let me show again raw IO, right? So this is what we did, right, in earlier lecture. I uploaded data into the S3 bucket, right, with the help of Glue. we then generate some data catalog. Okay, and after generating this data catalog, okay, after generating this data catalog with the help of Athena, I showed you how we can query it. One option we see was data catalog got generated. We can create the ETL with the help of glue visuals, right? So here I just the data that I had in data catalog, I just drop some duplicate from it and move data from enrich layer, move data into the enrich layer. So the use case was upstream system was putting data into my S3 bucket, okay, in these two folders. What AWS Glue was doing, it generated the data catalog, and with the help of ETL, we just drop this duplicate and move the enriched data into this S3 bucket, another S3 bucket, and then on the enriched data, we apply some transformation and move that data to the business layer. And of course, I told you that in business layer, once data is business layer, the quick you are basically a visualization team, right? It will work on that clean and process data and generate some dashboard out of it. So that's what we see in earlier lecture. I also told you that though the use case we talked about only in with perspective of S3 bucket, but we with the help of Glue we can connect to your DynamoDB, RDS, and all these things and create the catalog out of it. And once you have the catalog with the help of Glue visuals, you can connect to those logical table. This logical table would be in data catalog, and you can do visuals with the help of ETL visuals, right? You can do the drag drop operation to apply some transformation, remove duplicate and all, right? So all this ETL operation you can do and move data to the next layer. So that's what we seen. And yeah, and also we seen another use case, right? So in here you see we use AWS ETL visuals. We did the same operation in this case, but here we did AWS ETL notebook, right? So with the help of notebook, I showed you how you can these things is same. You got a data catalog, right, from these sources, and then with the help of ETL notebook, your PySpark notebook, right, you can connect to these tables, do some data manipulation, and move data to the enrich layer. Then again, with the help of Glue, you can read data from that enrich layer, do some further transformation, and then move data to the next layer. So this is what next layer, that is business layer. So this is what we seen, right? And further story is same, that you can again view that with the help of QuickSight and all. QuickSight is just, guys, just to let you know, it's a visualization tool. Okay. And then we also seen one more use case, right? DynamoDB. I told you what are the NoSQL databases, right? And I gave the example of NoSQL database. What is the purpose of NoSQL database? What is the limitation of NoSQL SQL database? That SQL database, because of which NoSQL is more favorable in some context, not in every context. There is still, it's a design decision that when you are designing some system. I told you, if transaction management, complex SQL joins, is that something your goal, then we should always go with SQL databases. But if data volume is very high, right, the frequency, the amount of frequency that you are getting data in is very high, and you are mostly interested in analytical operation, not a transactional operation, then NoSQL is a choice. So we've seen that with the help of upstream system, we call one with the help of uh, uh, basically with the help of API, we call with the help of AWS Glue Notebook, we call API, and that API give us some response, and that data we then load into the DynamoDB. That's what we seen in earlier call. And then I further explain that, okay, once you got a data in DynamoDB, you can do the further transformation with the help of Glue Notebook and Glue visuals as well. So that's what we talked, guys, in earlier lecture. Now, guys, if you see the common pattern, let's say in these two, now I'm focusing, shifting toward what we will talk today. Okay. Now, guys, if you see, the common thing is between this system. Let me take a marker. Yeah. Common thing between this system, right? this is other case. Okay. If you talk about these two systems, what is happening? Upstream system is loading data into your bucket, right? This bucket or this bucket. And I told you in Glue, you have option to run job on demand or after every 1 hour. So what is happening? You are running your job after every certain frequency to see if data is there in this bucket. Now, imagine that uh, you start a job at to run it after every 30 minutes. Okay, for example, you start at let's say 8 p.m. Data is there. Upstream system, let's say, put up some data. Let's say before 8:30 or whatever, because upstream system is not in our control. Upstream system is a system which push data into the your S3 bucket. So that is something you have not decided. This system can push data anytime when that system have data available. Now let's say data got pushed and use trigger to job run at every 30 minutes. Okay, 8 p.m. let's say job started. Your Glue AWS Glue job started. It see data is there in S3. It process the data and move to these layers. Okay, it move data from this to these layers. Fine. Now again 8:30 next job would run at 8:30 because you ask AWS Glue to run your notebook, okay, to notebook or whatever visuals, ETL visuals after every 30 minutes, right? Analytic activity you told AWS Glue to run after every 30 minutes. At 8:30 it run, it see if data is in S3. Yes, data is upstream system load new files between 8 to 8:30. So that new files then again move to these layers and it gets stored to the business layer via same things, drop duplicate and applying some transformation. But let's say between 8:30 to 9, okay, upstream system not put any data into this bucket, but still your AWS Glue will read data, will try to see if data is there in S3 or not. If data is not there, I told you that with the help of AWS Glue, how we can AWS Glue help you to scan or to read only those files which not scan earlier. So what AWS Glue will do, it will see, okay, I have some files, but they have those file I already scanned. Now I don't see any file latest. So Glue will not, since upstream system not send any file in latest batch, Glue will not process. But thing is, at this time, you still your AWS Glue still need to spin up your cluster, and that cost of spinning up your cluster, you need to bear with that cost. Plus, this way we are not utilizing our resources effectively, because imagine guys, in 24 hours, if upstream system is not sending data into my S3 bucket, let's say 15 time, okay, or 20 time, for example, in 24 hours, considering frequency of 30 minutes, okay. My job is AWS Glue, let's say job is running after every 30 minutes, right? And imagine upstream system not frequently sending data. And so if we talk this way, in 2048 time, right? So our AWS Glue job would run, if I schedule job to run after every 30 minutes, then AWS Glue job will run 48 time. And imagine guys, if out of 48 time, 20 time, let's say I don't have data in S3, then isn't it the waste of resources? Because we are spinning up our cluster and we are seeing, okay, no data, then stop it. This way, we unnecessarily bearing the cost of AWS, basically spinning up a cluster, right? And this is also not the best way to manage the resources as well. So what's the solution then? So solution is event driven system. Now, when I'm saying event driven system, right? Let me take you to the event driven system now. 1 second. me just reduce. Okay. So what is event driven system? Okay. In event driven system, guys, rather my job, okay, my job to run after before every, to run in every 30 minutes and see if data is there. Rather than that, source system, it will generate some event and next processing happen. So this way, so what would happen here in event driven system? Your source system, the moment let's say file get put into the S3 bucket, data processing would happen. This way, no matter in 48, so if we are saying running in every 30 minutes, so in 24 hour we have 48 during 48 runs. No matter, even if I don't have data 20 time, I will not spin up my cluster unless until means AWS Glue will not spin up its cluster automatically until data is there in S3 bucket. The moment let's say event happen at a source things, okay, let me take a marker. Yeah, the moment the event happen at a source side, it will generate it will spin up, it will start the next process. If no file got put, it will never start, your next process will never start. So that's what the event driven system. Now guys, let me take you to slide to explain more details about this event driven system. So we will with other see, with the help of event driven system, we will be covering other topics as well, because today we are going to demonstrate event driven system with the help of synchronous processing, data processing, and serverless architecture. So this is the second topic we will be covering today, async data processing, and then it's asynchronous data processing, and then serverless architecture. Okay. Yeah. So these three things we will be covering in event driven system itself. Okay. So we are targeting event driven system, but async processing and serverless architecture also I will be explaining today with the help of the demo that we will be I am covering today. So now let me take you to my slides. Okay. So before starting event directly, getting into the event driven system, let know the component of it. Okay. Because there are some services in AWS which help you to build this event driven system. Okay. As you see my screen, I'm talking about those services now. Okay. Which will be helping us to build this event driven system, serverless architecture, and async processing. So first let's talk about AWS Lambda. AWS Lambda is guys serverless system. Okay. It yeah. It's a serverless computing service provided by AWS. It allow you to run code without provisioning any server. Okay. It execute code in response to the event that automatically scale resources as needed. So what it mean? First of all, you don't need to buy any server in this case. Let me take. Okay. You don't need to manage any server. Imagine guys, let's say you need to build some solution with the help of some, let's say Python. Okay. One of the way, okay, you take VM, right? You use VM from Azure or AWS, whatever, right? And install the Python on top of that, and then deploy your application, right? And then, of course, when that application, you need to make that application accessible outside of world, right? So there are lots of things that you need to do if you are trying to do things on, let's say, EC2 VM. Let's say you are deploying some solution on EC2 VM. But imagine, guys, I have a very simple function. That function is, the job of that function is just to call one API, do some calculation, and send the response. Don't you think creating the separate EC2 instance, applying some installing some Python library, making that application accessible outside of Word. Isn't this extra overhead I am doing? Wouldn't it be nice if I can just add that piece of code into the AWS Lambda and that function would run in response to the event and all, right? So basically, whatever the code I have written over there, if that code is very less in term of size, and I know that even it take the less duration, if that code I know that it would not take more than 5 minutes and it not need more than, let's say, s- s- it not need the more memory basically. So then AWS Lambda is the best place to move that code from that EC2 to AWS Lambda, and it is a cost effective as well, right? So what are the main points of AWS Lambda? It's a serverless. You don't need to worry about managing server, operating system, in infrastructure, anything, right? AWS Lambda handle all for you. Event driven. The way Lambda work, it support multiple feature. You can run it in the form of cron as well, but it mostly used in industry for event driven things. So let's say the moment event happen, such as new file being uploaded, it perform its task. Okay, so that's the one of the example, event driven. Okay, so moment, let's say new file uploaded to S3. Okay, or let's say the message received on Amazon SNS. So what is SNS, guys? SNS is a notification system. There are some notification system in AWS as well, SQS, SNS. Will be talking about simple queue service. We will be talking about SQS today. Okay, so it's event driven, pay as you go. You need to pay only for your compute time. Okay, scalable. It can scale to handle your increased workload as well. So if let's say you are getting multiple notification from the source end, it scale automatically accordingly. Then it's also flexible, guys. You there are multiple programming language. I will show you when we'll be creating Lambda today. We can use to create with the help of multiple programming language, we can create your solution in Lambda. And of course, it's a cost effective because imagine, guys, cost of having one server versus a cost of having single Lambda. You will be always having less cost when you are using AWS Lambda. Okay. Now we talk about AWS Lambda. I will be taking you through in console when we will be creating that. Let me move to the next slide. So this slide explain about difference between Lambda and EC2. As you see, Lambda is, let's say you have some, when to use what, right? It's not like EC2 is, EC2 is, let's say, a bad thing. Let's stop using EC2. There is some pro and cons, right, of each thing. See, AWS have limited timeout, time things. Okay, if you know that your execution will not take more than 300 seconds, best to go with the Lambda. But if you have some execution which might take more time, 30 minutes, for example, or 1 hour in worst case, then EC2 is a good choice. Okay, then see, in terms of dependency, AWS Lambda constraint come in the form of max size of 50 MB. So there is a limit in terms of whenever you are doing writing some, basically, if you are, let's say, writing some code, right, and then adding some dependency, let's say you need some jar file, right, or some other dependency. Let's say you are writing some Python code and you need some other dependency, right? When I'm saying dependency, right, guys, let's say you need some extra jar or let's say some Python library to run your code. There is some limit when it comes to the Lambda, but there is no limit in EC2. You can, let's say I'm running one program, I can use any number of amount of dependency as long as my storage volume is available, right? Of course, EC2 is not having constraint in terms of dependency. Guys, when I'm explaining, if any question, please ping me, interrupt me, not issue. And scalability and concurrency. AWS Lambda scale dynamically in response to the increased traffic. Okay. Whereas in EC2, EC2 put business in full control of implementing the concurrency. So it's you that you need to decide and implement your concurrency mechanism, right? If I am running something, if I take up some Python code or Java code, whatever, right, and running that in my EC2 instance, all the things that how my program should handle a concurrency, right, with the help of multi-threading, you say, or thread pool execution, you say, that knowledge and that logic I need to implement. Whereas AWS dynamically responds to the increased traffic automatically. That's one good things over here in Lambda. Whereas in EC2, you need that knowledge in concurrency pool and other things, right? And thread pool and multi-threading, all these things. Availability. Lambda charge for the amount of time function are up and running. So it charge only. So let's say you event driven system we were talking, right? So let's say it if you are running, if you have some event to run after every 30 minutes, and after every 30 minutes, let's say you have designed your solution in such a way that Lambda would get trigger only for these 48 minutes, sorry, 48 durations, you will get charged for. So since you you have designed your solution to run after every 30 minutes, so in 24 hours, you will be having 48 minutes, right? Then you will be charged only for that time. Whereas in EC2, no matter it's a 48, 20, or after every 5 minutes or once in a day, your EC2 should be always up and running and you need to bear cost of that. So that's the main difference between AWS Lambda and EC2. So these are the compute system, guys. So you should be aware about when to use what and what is the pro and cons of each. So I told you that it's not okay, AWS EC2 is not good. There is specific use case which I explained, right? And based on that use case, you need to use. Let me go to the next slide. Now, guys, we talk about S3 and these things. Oh, sorry, we talk about Lambda and difference between Lambda and EC2. Let's talk about another service today. We'll be explaining because if I directly move to the console, AWS console, and started creating these things, this might not be helpful for you. First, you should aware that what these systems are. What is SQS? It's a simple queue message service, okay, provided by AWS. It's used for sending, storing, and receiving message between the different software component of applications, enabling async communication and decoupling of services. So what's the meaning of it, guys? If let's say I have two service, okay, let's say I have two service A, service B. I'm writing something. Oh, 1 second. Why it's moving? Okay. Let's say service A and service B, for example. If I want this service A to talk to service B, there are two ways. Either I call, let's say, service B API. Okay, let's say this is a B. Okay, and service A. So there are two ways. Either I call the API of service B, right? And service B API would respond me, but till that time I need to wait, right? My API call would be in waiting state, in queued state until we respond. That's called synchronous messaging. But what async is? Let me remove. Wouldn't it be nice if, let's say, let me use this way, service A, service B, right? And there would be another, let's say, service. I will pass my message to this service. So what I will do in this case? Here. I will pass my message to this service, and this service will pass the message that I passed to this service. This way, I will be this service, this service, right? This service is not having any dependency on this service. I am just passing this message to this particular service, which will be SQS in this case, okay? When I'm saying asynchronous messaging and decoupling of service. Now this service and this service is decoupled. They are not dependent on each other, right? And the moment, let's say this service, okay, let's say my service A called, give some message to this service, okay, and the message is pulled by, let's say, this service. Now what will happen? This service would respond and send message to the this queuing mechanism. It's called a queue, let's say. What is now what will happen? This system will read data from this queue. So you see the way we decouple these services, right? And how async communication happen in this case. And this is a very simple example I gave in draw, or maybe I can explain in a great more detail. But yeah, this is what's happening over here, guys. It's a asynchronous communication. This system is not directly talking to it. This A is not directly talking to B in this case. System A is not talking to B directly in this case, right? It putting some data into the queue, okay? We call is a queue, okay? This A system is putting data into the queue, and B system is reading data from the queue. And then B system is B system use that message, do some transaction processing, and put the message to the queue. Now system A read data from this queue. So this is what kind sync communication. Here decoupling also happen. These two system is completely decoupled. They are not dependent on each other. Reliability. Guys, when you are a system depend on each other, let's say in earlier example I give, right? Let me take that one. If I talk about this example, A calling B, right? And let's say B expose some API, okay? And let's say B system expose some API, right? So let's say if system B is down, this is your B system, for example, right? Or not down, let's say there is some issue in the code that system B is having, right? Your A system would get failed message, and this is not reliable things, right? Basically you the way you are doing, you not have the basically better control over here, right? Because you are calling the system B which is in fail state, not working properly. You are still calling API and you are getting fail response, and you are passing that message to the your end user. So that is not something good, okay? And so in terms of reliability, SQs ensure that message not lost and receive can be received reliably. In this case, guys, you call API, you not got response, and your message got lost. No one know now what happened. But what would happen in this above case? Let's say even if your system B is down, okay, the way it was down over here, or some error in B system, you put some message here. But even if after you putting use message, let's say B is down and not read it, but still the message would be available for future use. So that's what ensures the reliability of your message. Your message would never get lost. Okay, that's the main thing. Of course, it's a cost effective and pay per use service. And is AWS SQS offer two queue. It's a first in, first out, and one is standard queue. In standard queue, there is no order maintained. In first out, as name suggests, the first message would get processed first. And so that's how the first in, first out. These are the two queue types we have, right? Okay, so that's what just wanted to explain, guys, how we can deal with this decoupling and all, right? In Draw, we'll be seeing this in more detail. Fine. Let me go to the next point. Just a second, guys. Yeah. Now, feature of this queues, right? I was talking that SQS take some message and put it into the queue, right? So what is the message retention, right? It put the message in a queue from minimum 1 minute to 14 days, and 4 days is by default. So that's how, guys, you will never lose your messages. The way things happen over here, as I was explaining, let me take system A, system B, and there is a queue in between, right? The messages that you see here, right? Second, sorry. Yeah, sorry. So messages, guys, you will be getting in this section, right? In this queue, what are the messages you will be getting, right, from these systems, from this system? These messages will be written for default 4 days. Okay, that's way your this system will never lose your message. Okay, there are some other feature as well. Message visibility timeout, right? The once message is read, let's say once consumer read message, it become invisible for default 30 seconds. Let's say your system B read this particular message. Take lines. So let's say your system B read the message which is in queue. System A put message, B read that message, right? The moment it read, by by default it would be invisible for 30 seconds, so that there shouldn't be another processing system. Let's say, for example, I am having another processing system here, right? C, for example. Okay. So if message read by B for 30 seconds, it is not available for any system to read it. Okay. So that's how they maintain the message visibility timeout, so that we should prevent the duplication, because this message which is in queue is already processed by B. So system C should not read that message. So for that, they support a message visibility timeout. And you can increase that to the 30 minutes as well, so that system C should never get that message which is already processed by message B, right? And maximum message size, guys, you cannot pass, let's say, one big file of 5 GB or anything like that, or 1 GB even. This is what the message size. You can pass the limited message. Delivery delays, right? Message can be delayed up to 15 minutes before being visible in the queue, right? So that's what the dealing mechanism also it help you, right? So when source is sending the message, you can configure it to delay for 15 minutes before it visible to the queue. So there are some use case when people use such sort of things. And retry and redelivery. Fail message. So let's say message system A put message to the queue. Okay. Then if message while sending message to the queue, if system A failed, it will retry. And how much retry it should do, that is configurable. Let's say I told that in the system that try for 3 times, and then if not work, then consider it as a fail, because failure can happen anytime, right? So it will try for first time, second time, third time, and even if after third time nothing happened, then it will consider that as a failed message. Okay. So that's what, guys, a few important things when it comes to the this queue and SQS and how it works. Okay. Now, yeah, let me go to the next things. Okay. So now we talked about this thing, right? SQS, Lambda, difference between EC2 and SQS. Now talk about the serverless architecture. What is serverless architecture? Right? A serverless means, as name indicate, you don't need to create buy any server for that. Amazon create the server at a backend for your use case. Okay. So you don't need to manage, create the EC2 instance and deploy server, create EC2 instance, apply application on top of it, manage it. All this headache taken care by AWS services. what are all the serverless component? AWS Lambda is one of the example I just explained, but there are other as well, such as AWS Lambda, Amazon S3, right? It's also serverless things. API gateway, the API I'm talking about, right? One system need to call to the API. So if you wanted to use AWS storage for that, AWS provide the API gateway, DynamoDB, we talked in earlier session, right? And then event bridge. If you have some complex system, then we it also support even let's say one system calling to another, system B calling to system C, then system A again calling to system A, then system A calling to system C. So that sort of complex architecture if you have in your application, then Amazon Event Bridge also can help for your complex workflow. Okay, and benefit is see pay as you use, and of course you need to focus more on your business logic rather than maintaining the server and all, right? So that's what the importance of serverless architecture, guys. Okay, let me see how many slides. Okay, fine. So this is what is serverless architecture. These are multiple components of it. There are other components as well, and these components are available in all the things, right? It is available in AWS as well, Azure as well, right? Async data processing I explained, right? Now, guys, what we will do? See, async data processing with the help of Lambda and SQS, right? So what is async processing? I told you, right? It decouple it. I just gave. I explained you that with the help of these things. System A, sorry, system A is calling system B in async nature. How it's calling in async way with the help of some queue in between, right? So this is queue. So they are not directly dependent on each other. And now what are all the so will be what are the use case I'm talking about in async data processing? I'll be explaining that with the help of Lambda and SQS to you. Okay, and how the workflow would be. So producer will send message to the SQS. Okay, SQS store message until it get processed. Lambda pull the message from SQS. Okay, and Lambda process that message to the DynamoDB. So end to end these things we will be seeing. I have some draw or diagram for that one as well. So I will be showcasing to you. Okay. So this async data processing with the Lambda and SQS. That's what we'll be seeing. Since anyway we'll be covering this in Rio, I am not an driven architecture, right, guys? So let's do one thing because these are the same thing that I will be explaining now to you. So what we'll be doing now, we'll be implementing this event-driven architecture. So three things we'll be covering. Let me go to Rio. Three things we'll be covering: event-driven architecture, async data processing, asynchronous data processing. Okay, and then serverless architecture. So all these things in one use case we'll be covering. So the flow is I will be uploading some bucket to the S3. The moment I put some data into the S3, the moment I put some data into the S3, notification would happen. Okay, and Lambda would read data, notification happen, and Lambda would read data and pass that file, and there will be another Lambda which will process that data and store into the DynamoDB. Okay, so let's go to the draw guys to get better clarity of these things. Okay. Okay, as you see my draw screen, let me AWS ETL. Yeah, as you see my draw screen. Yeah, what we'll do, guys, I will be creating some first some S3 bucket. Okay, let me do that, and then we'll be creating two lambda one by one. Okay. So let's start first. And even while doing, I will just be drawing things over here. What's happening? Okay. So I'm having some S3 bucket over here in this serverless architecture. Okay. Wherein I will put some CSV file first of all. This is my S3 bucket. Okay. Now let me go to the AWS console. Let me, I'm in AWS console. I just search for AWS S3. Okay. Let me create a bucket. I'll be creating the bucket with the name. Event driven demo, for example. Let's see if this bucket name is available. We already created see, I'm in North Virginia region. Make sure that all the resources should be in the same region. I am giving the bucket name as a basically an event driven demo. Okay. I make this bucket to block all public access. Versioning I have disabled. I don't need it. Oh, tag and all I will keep all, it's optional. Okay. And I want AWS to basically manage the encryption. Basically what are the files I am uploading that should get encrypted, right? So I am asking AWS to manage with the help of S3 manage key. Okay, so I'm going with the default setting and let me see if that bucket is available. Okay, it's saying already that table name bucket name is available. So maybe we need to take some unique name. Okay, right. I just gave event driven elite as a name. Let me see if this name is available. Okay, this name is available, guys. Event driven elite. Let me go to the bucket. Okay. And then, okay, my bucket part is done. Now let's create another resources before doing anything over here. Now what I will be doing, I will be creating lambda. Okay. So the way it would be, sorry, the way it would be, this AWS lambda. Okay. I will explain how these two things will be related with each other. I clicked on lambda. So in lambda is it's let you run code without thinking about the server, right? That's what the main benefit. And these are all the programming language, guys. .NET, Java, Node.js, Python, Ruby, right? These are all the language that it support. So Lambda 1, for example, I am giving name and these are the guys programming language I will be using. Let's say Python in this case. Okay. I gave the runtime and other things I will be just keeping default and I will do create Lambda function. Okay. The way I create this function, I need in my solution another Lambda as well. So let me create that one as well. Now itself, I will be explaining that how, what's the purpose of that second Lambda and all. Lambda 2, Python, runtime system. Okay. And then architecture, I just wanted to use, these are just based if you want ARM 64 base or x86 64 base, these are the things you can go with default values. Okay, permission and all and roles and all I will be attaching later. I will be explaining what role I will be attaching. But for now, I just wanted to go very simple, create the Lambda function, use programming language and just create the function. It's a Lambda 2. Okay. Okay, guys. So my Lambda 1 and Lambda 2 are created. Now, just to show you how the things in AWS console, right? You see, the moment you go to the Lambda function, you see the code part over here. And this is what your Lambda function.py. This is very simple function, right? AWS Python function, right? So if I and what they input by default, it just input the JSON library. And if you wanted to put in a body, hello from Lambda, right? So that's what it put. It just returning hello from the Lambda in terms of JSON. Okay. Let me test these guys just to see if everything is good in my Lambda creation. Test event. Okay, I gave the test event and I saved it. Let me invoke. So you see, the moment I invoke, it show status succeeded, test name, event test. Okay, I got hello from the Lambda. I'll be putting some code over here, but just wait. We'll go one down. And in second Lambda also we'll be doing. Here also you see, this is second Lambda. Here also we have Lambda function. Now, here also I will be doing same thing. I will be just running this code. So you see the code part, monitor part, and other part are also there. But let's first focus on our specific thing. I will be just clicking on test, create new test event. Test event. And these are just sample key and value I am passing, guys. You can just, it just for your testing purpose. Whatever you have written is, whatever the piece of code is there, if this piece of code is working or not, just to check that you are running it. So you see, your second Lambda also got successfully run. It shows status as succeeded, and it responds with the 200. 200 is a code to ensure that everything is right. And you got a response as well. Hello from the Lambda. So my two Lambdas are ready, guys. Now what I'll be doing, I know that in this solution, I also need a SQS. So I will be creating the SQS. I explain you right in the PPT, what is SQS and all. So now let me click on, okay, SQS. You go to the global console and type SQS. It's a simple queue service. Just click there. Okay, I have few queues. So maybe I'll be creating, let's say, the new one I will be creating. Create queue. Demo queue. Okay, this is just for demo purpose I am giving. So guys, when you are creating the queue, it show you configuration, visibility. These are all the things that I took, right? I talked in PPT. Maximum retention period, how much time. So if I just show that PPT once again, you see, these are the things I was talking, right? And let me present PPT once again. So, right, maximum retention period, visibility timeout, message size, delivery delay. These are all the things that we need to configure, right? And I explained that how if you wanted to, by default, it's a 4-day, but you can configure how much time you want and all. So this is the same thing. It's showing over here. You can configure based on your requirement. It show visibility timeout. What is the meaning? How much time you wanted to make that particular message. The moment, let's say, you put some message in this queue, how much time you want it to be visible, visibility to the consumer. Okay, so that's what the visibility timeout. Then how much time it's a retention period, how much time you wanted to put that message. You can configure maximum 14 days, right? Minutes, hour, whatever, based on your requirement. Delivery delay, right? If you want the moment, let's say produce message, but you want to delay for certain duration. So how many minutes, second, that's something you can do. Maximum message size, right? It's a 256 only, and receive message wait time. So basically, when receive message, how much time it should wait. So those are all the configuration things, guys. You can configure based on your requirements. I will be going with the default one, whatever the value that AWS provided. Encryption, enable. What are the messages I am getting in my SQS? They need to be encrypted with help of AWS SQS key, right? So that my message should be encrypted. No one should read that message. Okay. Other things I will be just go as it is, right? Another one important thing is DLQ, right? What is, guys, DLQ? I will just talk now, but I will explain in draw what is DLQ. So let's say message failed. Okay, how, if that failed message you wanted to move to particular queue, right? Let's say you have messages into the queue and no one read that message. It's not got undelivered. Means consumer system not read that message. Then what to do with that message? After 14 days, that message would get lost. So in that cases, those failed message should be delivered to some other system. That is a DLQ. You can enable it and you can give the what is the name of that dead letter queue. In our case, we will not go with that case. So I will just be disabling it. But if you have some use case, you can enable it and you can give that name of that queue. So all undelivered message which are not processed by consumer, those will get moved to the this queue. So dead letter queue, DLQ we talked, right? We pronounce it as a DLQ. It's also the queue only, but queue of undelivered message. And guys, rest of the things let it be as it is, and I will be creating this demo queue. What demo queue, right? Yeah. Okay, it says queue created successfully. Okay, I have this demo queue, guys. Now what next? Okay. Now, guys, in this case, I also need a DynamoDB. Okay, because the way our use case is, guys, let me now, because I'm creating resource and maybe you'll be wondering what's happening now. Okay. So see, the way our use case is, we'll put some file in S3. The moment we will put some file in S3, the event would happen. What this event would do, this event would trigger Lambda 1. Okay. This event would trigger Lambda 1. What does Lambda 1 do then? This Lambda 1, 1 second, let me take that. Yeah. Yeah. What does Lambda 1 do? This Lambda 1 will read that event. Let me add this as an event. So this is event source. Okay. S3 is your event source. The moment, let's say, so the moment, what happened? Yes. Sorry. The moment, let's say, event happen, okay, at a S3, Lambda would get triggered automatically, not like above case that, okay, I'm continuously with the help of glue, I'm continuously reading the file from S3, right? Not that way. Now what happening, guys? Not like I'm continuously reading data from S3 with the help of glue after every 30 minutes or 10 minutes or 1 hour, whatever, right? The moment, let's say someone put the file in S3, my Lambda would get triggered. What I will do now? My Lambda, what will do? It will put that message into the queue. Okay, it will put that message into the SQS queue. So Now guys, there will be, okay, now message got put into SQS queue. What next? To decouple two system, okay, and to make two system talk to each other in asynchronous way, we are creating another lambda. You see that I created the two lambda. This is lambda 2. Okay, this is lambda 2. What this lambda would do? Okay, it would read data from this SQS. Let me label this name as SQS. It would read data from SQS, process it, and that data, it will be loading into the DynamoDB. What is this entire solution, guys? It's a asynchronous communication. You see, let me just take, you have two systems talking to each other, first of all, in async way. This system and this system are communicating with the help of SQS. They are not dependent on each other availability. Even if what is happening with the help of async, first of all, let's talk about this async nature, right? What we are trying to achieve over here. With the help of async data processing, let's say your lambda at 2 is down, for example, for some time. Even if it is down, your message won't get lost, right? And still, the moment, let's say your lambda 2 get up, right, after certain time, it will pull that message. Otherwise, guys, if this is sync communication, if I remove this SQS from this one, right, then these two system, if they will talk to each other, then imagine, guys, if this lambda 2 is down, all the messages that you have on that period will get lost. But with the help of SQS, now you have that reliability, your message would never get lost. So async communication happen between lambda 1 and lambda 2. Second thing is event driven. Okay, what is this? The moment you put some data into the S3 bucket, event get triggered. Earlier, what was happening? What was happening in this above case? Your glue continuously crawl up, checking data, if data is available, right? After 30 minutes, 1 hour, what, right? But now, and I told you, it spin up the cluster and see, okay, oh, data is not available, let's stop that cluster. Nothing to done. But the cost of spinning the cluster and all, you need to bear. Whereas in this case, it's event driven. The moment you put something data, then only your processing happen. Otherwise, nothing will happen. And serverless architecture, guys. You see, all the component you see over here, have you, are you managing any server for that? Okay, let me create a VM, install my Python there, right? Or let me create some EC2 instance and install my DynamoDB there, right? Nothing. This entire solution is serverless, right? So these are the main important things in this architecture. Serverless architecture, this is serverless first of all, right? Then it's async communication. Two systems are talking to each other with the help of some queuing mechanism, queue, right? And then it's the event driven as well. So event, the moment, let's say, event happen, then next things would start processing data, right? So this is what things happening, guys. Now, guys, as I told, we need to create a DynamoDB as well. So, guys, see, when I'm talking event driven, SQS is one of the example I'm giving. We also have some other examples. And if there is huge volume of traffic, right, then that particular use case we will be talking to, which is a Kafka. Okay. So for simple things, we'll be talking about. So if your message system are not that much, you are not getting billions of message every 5 minutes, right? For example, then SQS is a very good choice. But let's say if you are getting more messages, then Kafka. We'll be talking Kafka in next lecture, but I'm just giving. When it comes to the event-driven system, SQS is not the only one solution. There are other solutions as well, and Kafka is also one of them. We'll be talking that on by end of this lecture or tomorrow possibly. Okay, so now let's go to as we talk, we'll be creating the DynamoDB. Okay, let me, yeah. So let me now, guys, create DynamoDB table. I'm in DynamoDB console. I will go to the table. You see, I don't have any table. In early lecture, I talked about, right, DynamoDB details. There is a table. First of all, you need to give the table name, right? Then in DynamoDB, you have to give the unique key. Without this unique key, it will not work. So I know in my case, I am creating the order table, and in order table, I have one primary key. What's the name of that primary key? Let me just check. It's order ID. Okay. So partition key, basically they talked it, right? In DynamoDB, you need to give partition key and sort key. Sort key is optional, but partition key you need to give. On that order key only, it partition data, and it's a mandatory key, right? I explained all this detail in earlier lecture. And rest of the things, let it be as it is, right? I will not give any sort key now. But let's go with the default setting. Let's create the table. So now, guys, I have created the DynamoDB table. Yeah, you see, guys, how the things are serverless, and imagine, guys, with just one click, you create a NoSQL database. Even if today, if you wanted to use MySQL, right? For example, with non-serverless architecture, you need to get some VM, take some license of MySQL, install that MySQL license, and then starting using it. But you also need to take care of your VM availability and all, right? So how things are easy now. My my DynamoDB table with the name order is now in active state. Now, guys, let me put some code over here in Lambda 1 now. Let me maximize these things so that code should be visible to you guys. I'll be explaining this code line by line. Okay. So first of all, what I'm doing over here, I just mentioned, I'm just declaring few things, right, guys. First of all, I import some libraries which I required. Okay. Import statement. Boto 3 is one of the SDK. If you wanted to work with AWS in term of SDK, software development toolkit, right, SDKs, then Boto 3 is a library. With the help of Boto 3 library, you can talk to S3 buckets, you can connect to the SQS client, you can connect to the DynamoDB, all the things, whatever you are, I'm showing you, right? Create a Lambda, create SQS, create DynamoDB. All these things can be done via programmatically with the help of this Boto 3 client. Okay. So in my case, I need S3 client and SQS client. That's why I create this Boto 3 library and dot client and create these two client. And I give URL of my queue. Let me see my queue URL is same. Demo queue. Let me just copy this name. Okay. And this is my queue name. Okay. My queue also is North Virginia. My DynamoDB table also is same location. My two Lambda also at the same location, and my S3 bucket is also at the same location. So this you need to make sure to avoid any further challenges. Okay. I created a queue. Now what's next? I will creating now function. It's a very simple function, guys. Let me just paste that enter function. Okay. Let me take you line by line. So this is what the function I have created, right? The way AWS Lambda work, right? First of all, you need to pass event. You know that first before some time I create the event and just give this normal JSON. So in event driven architecture, you need an event. Event where event would happen? Event would happen at a source side. Okay. And that source side event we will get in the form of JSON. And what this event, what I'm doing over here, in this event, I am getting the name of the S3 bucket. 1 second. In this event, what I'm doing, I am with the help of, I told you, right? The moment, let's say, event happen. So earlier in day when I was running, I just give you this JSON, right? The moment event happen, what event? Let's say I upload some file in S3 bucket. The event would happen, right? That event is in the form of JSON. Now, from that event, I'm running with the help of these two piece of line. What is my bucket name, right? And what is the file name? Bucket name and my file name. I'm taking from that event JSON these two element, my bucket name and my file name. Once I got those things, with the help of S3 client, whatever the S3 client I have created, I am getting the access to that particular CSV file which is in S3. So I got response to that particular S3 bucket. Then, guys, from that S3 bucket, so I got a response, right? From that response, I'm just looking into the body of S3, right? What is the content in that S3 file? So that's what this line is doing. Once I got that particular line, sorry, particular data from that bucket, what I'm doing with the help of these things, what I'm getting the data in the form of dictionary. In Python, we have dictionary, right? The way I'm getting data in the form of dictionary, wherein your dictionary key would be your column headers, okay? And value would be in, let's say, what are all the values you have in row 1, right? Row 2, row 3, those are all will be the values. So this is how I will get data in the form of dictionary. So CSV dict reader is a class in Python. I can maybe make it, it's a Python CSV module that allow to read a CSV file as a dictionary. Okay. It read the first row as a, as I told, right? First row as a key and subsequent row as a values. So I will get data in this form, right? Now for, let me just undo that. Okay, yeah. Now for each, let's say I got a row, I got this entire data in the form of key value. I am then iterating this dictionary, right? And for each row, I am getting the message body. Let's say very first row would be, let's say very first row would be your headers, right? Then next row is and then all subsequent row would be your value, basically rows, right? First row would be header and then all other row would be the actual values. So all these messages I am putting to the queue. My queue URL I have given over here, right? Demo queue. And to call that queue, I am using Boto3 client, SQS client, send message, queue name, right? I am giving the queue name and message body. Whatever the row I am getting, that row I am putting to the AWS SQS. If everything got success, I should get the return 200, otherwise exception. So that's what this code is, guys. Let me now deploy this code. Okay. So code got deployed. So you need to deploy code, right? This is how you do deployment in AWS Lambda. one of the way, right? There are other ways, but this is one of the way. So you create this code and you deploy, right? So now guys, we are done till this part. Okay, write the code for this queue I already created. Now let's put the code for this lambda. Okay, so here also let me just put this same thing. I will be explaining you line by line. Why I'm not writing these guys? Because it would take more time and our session would get more lengthy, right? And I don't want me to type and you just see this. So that's why, just to make things in better way. So you see, this is the second code in Lambda 2. What I'm doing, first of all, I'm importing all these things that I need. Boto3 is a library, right? I had told if you want to talk to any AWS services, yeah, Boto3 is a library. Because I am dealing with the JSON data, I need a JSON, and decimal is one of the things that I'm doing with the help of my data set, right? I need that for that purpose. I need a data set. So I told you, right? The more what will happen, this event would happen at a SQS side. This is also, guys, event based things. So the moment event happen in S3 SQS, earlier the moment was happening in S3, this lambda would get triggered. Now the moment some event happen, now in this case, event source is SQS. The moment event happen in SQS, this lambda would get triggered. Okay, this is event source, and this is action. We will be taking action lambda in this case. Okay, in second here SQS is the event source, but action SQS is the event source, but action is lambda 2. Okay. Now what I'm doing, whenever let's say new message got put into your SQS, right? The moment message got put into your SQS, let me take a marker. Here. Yeah. The moment let's say message got put into your SQS, okay, this lambda would get that event in code. What I'm doing in code, what I'm doing, I'm getting that event. From that event, I am reading these records. Okay, I'm just first of all printing that event, and from that event, I am getting the records. Okay, the record is a variable which is available in that event. Okay, now for each record, guys, what I'm doing for each record, I'm getting the basically JSON.load and particular body of that record. Okay, basically I'm getting the message from that whatever I'm putting here in SQS, right? Because I'll be putting message one by one, not all everyone, right? It's a queuing mechanism. The moment I will put something over here, this lambda would get that event and it would read that particular record in the form of event, right? So you see from that, and of course, event we will get in the form of JSON, right? So from that JSON, I'm just getting the record body. Okay. Once I get that message, I apply some logic. Okay. This logic, what I will be showing CSV file as well, CSV file as well, right? I apply very simple logic. Okay. If my price of my particular order is greater than 100 and it's in region East, US East, okay, then only put that record into the DynamoDB. That's what a use case, guys. Okay. Otherwise, it will not put that data into DynamoDB. Otherwise, it will skip. So this part clear, guys? The event would happen in the form of JSON, right? I will get that event, and then from that event, I will get first of all the records. It may be possible that in one event I get the 3 records or 4 records or 1 record. But I don't know, because event will not have, there is no control that how event would happen. Or it may be possible that I will get, let's say, at one go, I got a 3. Let's say in my CSV, I have 10 records, for example, which I'm uploading over here. First of all, 3 record come, event would happen, and it process this 3 record. Then 4 record would come. Then it would process this 4 record. So that's why you see, we apply for loop. The event, I'm getting the event records, right? And then all records, for all record, I'm just getting the body, right? And then from that body, I'm just getting the actual message. And then on that message, that record, I am applying filter that I need just only this condition, filter condition, price is greater than 100 and region is equal to East US. If that is the case, then only putting to the DynamoDB. How I am putting DynamoDB table, guys? See, I create DynamoDB. First of all, I connect to the DynamoDB with the Photo3 library, and this is all the table I have created, right? Here you see, I have created the table with order names, orders, right? Orders, right? Once I got the reference to that table, table dot put, and that particular item, whatever item, right? Message, whatever the row that you are getting, you are putting that row in DynamoDB table. That's what the code is, guys. Let me deploy this one as well. Now, guys, after, okay, it's deployed successfully. Now, guys, there are other things that we need to do. Let first go to the Lambda one, okay? Because since these are different system and they need to talk with each other, right? So we need to do some role assignment. Let me click on a Lambda one. I go to the permission. I will click on this role. Okay, let it get open. Okay, I got this role. Okay, now you see, guys, there are some roles over here. Okay, by default, AWS Lambda basic execution role you will get, but you need some additional permission. Okay, what I'll be doing, let me just move this. Yeah, take this down. I will be creating some, I will click on add permission and attach some policy. Since I know that this Lambda would talk to S3 bucket and SQS, right? This Lambda would talk to S3 bucket and SQS. So that's why I will be giving accordingly access to this queue. Okay, add permissions. Okay, S3. In this case, I am giving S3 full access and SQS full access, right? Add permissions. You see, I assign the Lambda which is associated with this, the Lambda one, right? Basically, I give Lambda one role, and to this role, I attach some more permissions, that is S3 full access and S3 full access and SQS full access. Similarly, my Lambda 2, I know my Lambda 2 need access to SQS and DynamoDB. Let me give that. For Lambda 2, I will be clicking on configurations. Permissions. I will be clicking on this Lambda 2 role. There is a basic Lambda execution rule would be always there when you will be creating the Lambda. Let me attach some policies. Since I know that my Lambda second need access to SQS and DynamoDB, so I'll be applying those rules over here in Lambda 2. SQS. Guys, I'm giving full access, but when you are giving SQS a role in your actual maybe restricted environment, okay, and DynamoDB full access, then you should be always restrictive to give the access. You should not give the full access, but just for this demo purpose, I am giving the full access. Let's say I can do SQS read only access or DynamoDB only put access. So that sort of nitty-gritty you can do, but just for this demo, I gave the full access to DynamoDB as well and SQS full access as well. Okay. Now this role got created, guys. Okay. So my two lambdas having the right role now to talk with, let's say here S3 and SQS, and this also have a right role to talk to SQS and DynamoDB, right? Now, okay. Now guys, when I am saying event driven, okay, we give a role and all, right? But how the moment, let's say I put the file in S3, how the event should get triggered? What is the way? Okay. So for that, let's go to the S3 bucket. Okay. Currently there is no file over here, right? How to ensure that what we need to do, what we need to do so that event would happen whenever I put some file over here. If you go to the properties section, you see there are multiple things: bucket versioning, tags, default encryption, right? These are intelligent tiering and all. This is my things which I need to focus to. Event notification. The moment, let's say someone put the file, I want to create an event notification. I will click on this. I'm just giving name. I want any file if got put into this bucket, event should get triggered. I click on event. I am more interested in if someone is putting the file, means put operations means adding, updating row, or adding new row, or creating completely new file. Okay. So I'm more interested in only two operation, put and post. So put is, guys, what is put operation? If you are updating, let's say, particular row in S3, right? Or adding a particular row, or you are adding completely new file. So for those cases, I just more interested in put and post, but you can use other option as well. Okay. So guys, see, these are all the actions event basically on which you can trigger your event driven system. Currently, I am interested in these two only. But if you want, if object removal, then to event happen, or if object restore, then to event happen, right? If someone change the permissions of object, then you want event to happen. So all these things, right? You can generate the event. Let's say your S3 object is basically a life cycle, right? When your data move from a raw to, let's say, hot tier to cold tier, then you want event to happen. So all these things you can generate event for, right? Intelligent tiering. Basically, S3 look your data access, and based on your access, it move data from higher tier to lower tier. So you want, let's say, if you want the event to happen that time, that also possible. So these are all the things. For our case, we will just be going with these two options, put and post. Okay. What is the destination of this event? Destination is, guys, my lambda 1. I'm putting using this lambda and I'm saving this configuration. Okay. Now, guys, this event things completed. So now this event logic got completed. But we also need event at this side as well, right? The moment message got put into the SQS queue, lambda should process it. So for that, let's go to the lambda 2, right? Before going that, guys, the moment, let's say I this thing, no, let me refresh lambda. I showed you that after I enable that event, you should see S3 bucket over here. Okay. See, you see. Okay. Before going to lambda 2, guys, we need to complete another thing, add a destination, because this lambda will put data to the SQS queue, right? So let me add a destination over here. Async communication, right? That's what, guys. We are communicating to system with the help of asynchronous mechanism. I want the moment, let's say, successfully message got put. Okay. I want, let's say, the moment some message got succeed. I don't want a failure mechanism, failure way. So let's say if this lambda execution got succeed, then it should put message into the SQS queue. Okay. So for that, what I did, sorry, yeah, I mean lambda 2. Yeah. So on which condition? The failure event processing or successful invocation? I'm more interested in successful invocation. I will give my queue name and I will give my destination queue, right? It's a demo queue I have created. Let me save this. You see, guys, now your Lambda got two things, S3 as a source, SQS as a destination. Okay. Similarly, for Lambda 2, let me just refresh. Okay. For Lambda 2, guys, what is my source, right? For Lambda 2, my source is, in this case, is SQS. Just a second. Okay. I'm going to permission. Okay. Anyway, S3 full access and all I have already given. Let me just check the roles. From here. These all rows are already there. Let me add the source over here. Add it. Okay. Let me add a trigger. Okay. Maybe we can do it different way as well. Instead of me adding trigger over here, let me, yeah, this way I wanted to show you. Multiple ways, right? See, now I have this Lambda 2. Let me click add trigger. No, I am not getting that particular things. Trigger source SQS. Okay. Yeah. Fine. Let me click on this SQS. Okay. The queue I will be using demo. Okay. And let other things be as it is and click add. Okay. Now guys, this, as per this architecture, this Lambda 2 will pull data from this SQS, okay, and put into the DynamoDB. Let me add a destination over here as well. Okay. Now guys, important thing. In this case, if you see my code, I not need to add a destination because that I have added in my code itself. If you see Lambda 2 dot this thing, Lambda 2 function, right? I am calling the DynamoDB from the code itself. So if I am doing something from my code with the help of right libraries I have, let's say Boto3 in this case, then you don't need to add destination in this case. Your code itself, it will do automatically. It will connect to DynamoDB table with the orders and it will put data there, right? So that's what we are doing over here. So now permission, I think, yeah, we have added all the permissions. Let me see if limit. Yeah. Now I think we have added all the permissions. So guys, let's do one thing now. Let's upload some file over here in S3. Let's see if everything is good or not. So I have one file. The name of the file is order.v1. I can just show you guys this file, how that look. So this is very simple file, guys. As you see on your screen, this is the order.c order v1, right? The name of the file. And I have a few orders here. Order 1, 2, 3, 4, 5, 6, 7, 8. Okay. And right. And I have ordered v2 as well. Order v2. But let's first upload this file. Let me stop sharing. Let me share the console. Okay. Let me upload guys file. Let me see if everything is correct. Have we done all the things which is required? Create SQS, create implementation key. Okay. And SQS. Go to the queue. Okay. You see guys, there are multiple way I was trying to show you, but this time I have enabled, see, I went to the Lambda 2 and add a trigger as a SQS. Alternatively, what you can do, you can go to the SQS and create the Lambda trigger from here itself, here as well, right? Configure. Now, since I did from there, it show you that Lambda from here as well, right? Configure Lambda. You can do from here as well. That's what I was trying to show you. But anyway, we create from some other another things. This see Lambda 2, right? So now we got the Lambda 2 over here. So there are two ways. Either you can configure from your SQS or you can configure from your Lambda. Okay. Anyway, now let me upload files. Just a second. Let, let me upload that particular file. Okay. I have uploaded this order v1.csv, right? Now guys, the moment let's say I upload, just wait. Okay, file got uploaded. Let's see if you see guys, I created this order table, right, in DynamoDB. The moment I uploaded those record, all these record I got into my, if you are seeing my this screen, right, DynamoDB things. All these records are available in my DynamoDB. So what happened now? Order. So it scan all data, but see, if you notice that in our order file, what are the file I was show order CSV file, right? I showed you that I have this data to upload, right? But it have 7 record. If we count from the record number 2, it have, if you ignore header, it have 7 records, but out of which we got only 4 record. Why? Because in our code we add a logic that we just need the data which is in US East, okay, US East, and the price should be more than 100. So that's why this record not come and this record also not come. As you see in my code, lambda 2, you see, I apply this filter, right? I need only East US, and if the price is greater than 100, then that record should get put into the DynamoDB table. And that's what you see, guys, right? All the record are of US East, okay? And all are greater than 100. This is how, guys, this end-to-end communication happen. What happened in this case? Let me show you that diagram once again. I upload the file. The moment I upload the file, this event gets triggered. That then that event that data get put into the SQS queue. Let me go to the SQS queue. Let me see, click on monitoring tab. Sometime you see spike, you see right here, some messages come and it said, it show that message count and all, right? So it show that it received those many messages, total records, right? And after getting those number of messages, we then again apply the filter, right? With the help of lambda 2. And then that process data, we load it to the DynamoDB table. So this is how, guys, these end-to-end things happen. Now, guys, let me do one thing. I have another order V2 CSV, okay? In this case, let me show you that order v2.csv. You see, I have some more record, order 8, 9, and 8, 9, but I have also have one duplicate record. Okay. And you know that from earlier lecture, DynamoDB help us to create the partitions key, right? Partition key to make your data unique. So let's say if in your event source there is duplicate, how our system handle that thing? Let me upload this particular file as well. Okay, just give me a few seconds. Add files. Okay, I'm sharing my screen once again. As you see, I have uploaded the same order v2.csv. I clicked on upload. Now, guys, let me close this. You see, I have order v2.csv, right? Now, the moment I upload the file, all these things happen. It lambda 1 read it, send to the SQSC. Okay, if there is any data record with the region US East and count greater than 100, then it will put data into DynamoDB. All these things should happen the moment I upload some data, the moment I did some event, right? That's what the guys event driven system. I upload the file, event happen, the lambda process it. The moment event happen in SQS, right? Lambda 2 get into the action and then it upload data into the DynamoDB. Let me show you now DynamoDB. Let me refresh. Earlier there was 4 record, right? Now, guys, let me see. CSV. Let me click on a monitor. 1 second. Okay, I think maybe try. Let me try to do one thing. So guys, when let's say I upload the other file, and ideally we should see data for that one as well. But the main important thing is, guys, the moment let's say you upload any data into the your this S3 bucket, right? The moment you upload, the event should get trigger, which we seen in earlier case, and we got the data into our DynamoDB table. Now, when your Lambda got executed, guys, if you wanted to see the logs of it, how to see that logs and all, I will just show you that part as well. Configuration let me click on a monitor, right? You see the CloudWatch logs, right? So when your Lambda got execute, if you wanted to see the logs and all, this is all the logs things that you guys, you can see what's happening in the logs and all. So you see that object, this is what the event that I print the event in my code. So this is what the event, guys, right? And you can see all the data you are getting in this event. So this is how, guys, things happen. If you, let's say, when you are running the code and you wanted to see logs associated with that, this how can you see your logs and all, right? Ideally, sometime what happened when we upload a second S3 bucket, we should receive that data as well. But let me do one thing. I don't know if it not take that event in the right way. Let me delete it. And let me upload it once again. Order v2.csv is having the right things. Let me stop sharing for a second. Upload. Oh, I think, yeah, guys, we made one mistake. Everything happened properly as well here as well, but just we not notice the data. Let me show you data. What the problem was in data set itself. So you see, not problem, but the way this data set is defined is you see order 1, 2, 3, 4, 5, 6, 7, 6, 6, 5, 6, and 8, right? And then here I am having 8 and 9. So if I go to 8 and 9, right? So I was expecting record for 8 and 9 as well, but you see, first of all, 8 is a duplicate, guys. 8 record is available here as well. Okay. If you are seeing my this screen, 8 record is available here as well, and 8 record available is here as well, right? That's why in DynamoDB table, we got only one record for 8 because partition key we apply for order key, right? And why we not got a record for 101 as well? Because of course, 101 is, first of all, it's West US, right? US West. So it will not come. And why I not got this one as well? It is also from US West, right? So that's why these two record I not got. From the second file, I supposed to get only one record, that is this one. But since I already got this record from this data set, that's why you can see in my DynamoDB table, there are still same number of entry, which are 4 only, and that's completely valid. So this, you see, guys, I upload order v2 two time, but still result will not affect over here because DynamoDB manage with the help of partition key and all, right. It manage the unique things for your to maintain the unique constraint, right, in your database to avoid duplicacy and all. So it manages those things with the help of the order key that you give. So this is how, guys, these end-to-end things happen in the serverless architecture. Earlier, I was thinking that after uploading this file, why this order V2 CSV, why a new record not come? But I just explained it's a data itself the way it's designed. From this data set, only in my first data set, I have order 1, 2, 3, 4, 5, 6, 5, 6, and 8, right? And from that, I just got the 4 record order this one, right? Then this, right? And then I got first one. Only 4 record I got. But when I upload a second file, since order 8 is already available from this one, right? That's why it not come. And these two are anyway US West, so they will not come. So that's why I have only 4 record in my dynamic table. So this is what, guys, I wanted to show you how this async data processing happen, right? Two system talk to each other in event-driven system, right? And in async manner, right? This system and this system is not in sync with each, not dependent on each other. They are talking asynchronously with the help of SQS. Now, guys, I have some other thing as well. We talk about those things, right? But what if you have very huge volume of data, okay, coming in, millions of record, let's say per minute, okay, or per, let's say, 5 minutes. In that case, SQS might not be the good choice. It's a design decision, okay, you need to take when you are working in project. In those cases, you need to work in some other system, that is a Kafka, right? I will get into the more detail of Kafka in tomorrow's lecture. I will explain that Kafka architecture, and we will also deploying one solution on Confluent Kafka. Confluent is the solution. Basically, Kafka is Apache Kafka developed by some developers who were in LinkedIn, and then they open source it, and the same developers then develop the Confluent edition, premium edition of the Kafka. So we'll be doing some on first of all, we'll learn the Kafka architecture, and then we'll go to the Confluent Kafka cluster creation and other details related to that. I will explain other things. So maybe this is what I wanted to end today's lecture. We will talk about the Kafka. What is the Kafka? How it's different from the SQS, right? I just mentioned that if that data volume is very high, sorry, then Kafka is a better source than SQS, right? And all right. So let's talk other detail on Kafka in tomorrow lecture. I think we can come for today's session then. Any question, guys? Okay.
No, sir. Clear.
Okay. Okay. Thanks. Then we'll talk to you in tomorrow's session then. Thank you very much.